Good evening, sir. Nagaraj, sir. Welcome, sir.
Evening, sir. So I thought today you will not be there.
Sir?
I thought today you will not be there. You might be busy in some other way. I thought like that.
Yes, sir. Tomorrow, sir. Tomorrow and day after tomorrow. Duty, sir.
Good evening, everyone.
Sir, wait for 10 minutes, sir.
Okay, sir. No problem.
Thank you, sir. Nagaraj sir. Nagaraj sir.
Yes, sir.
Sir, you can start the session, sir.
Okay, sir.
Thank you, sir.
Good evening, everyone. Welcome to day 13 of our practical approach to implement data structures using C short-term training program. On behalf of the Department of Computer Science and Engineering, National Institute of Technology, Nagaland, and the host institute, Swarnandhra College of Engineering and Technology Autonomous, I warmly welcome you all in this wonderful evening. So yesterday, we started the concept of double linked list, and we could write the implementation of how to create the double linked list and displaying the nodes of the double linked list. Today, the actual schedule is about insertion and deletion scenarios of double linked list. If time permits, I would like to start the new variant, that is circular double linked list, if time permits. So let us quickly start our session. Let me share the screen. So today our session begins with, hope all of you are excited to learn some more concepts about how to make the programming with ease, how to write a program with ease without difficulty, right? So almost from beginning of the linked list, each and every linked list is a 250 line program. So almost we could write, including stack, queue and all, 1000 lines of code till now in 12 days. That means on an average daily we are writing 100 lines of code, right? So let us try to start our concept of inserting a new node in the double linked list. Inserting a new node in the double linked list. Okay, let us start the session now. So we are going to start the concept of inserting a new node in the beginning of the existing double linked list. Existing double linked list. That's the scenario that we are going to handle now, and let us see the logic of it. Imagine there is a existing DLL. Existing DLL. Imagine there are 3 nodes in the existing double linked list. So let us not worry too much about the data. We will try to understand only the concept of how to handle the addresses. By this time, everybody might have already understood the power of the concept of pointers. If there is no concept of pointer, data structures implementation might not be very fruitful. So in double linked list, first node previous is null and last node next is null. And there is a two-way connectivity. So imagine this is the base address is 1000 and this is the first node. This is the first node. And just imagine the other base addresses are 1000, 2000 and 3000. So this is the existing linked list. Now, what are the steps involved? What are the steps that are involved in creating or in adding a new node in the beginning of the DLL? So let us see the steps one by one. Step one is always creating the new node. Step one is create a new node, read the data and keep the previous and next node addresses as null. Keep the addresses as null initially. So obviously you are going to use malloc statement. Then reading data. So I hope everybody understood how to create, right? I think there is no need for me to write new node equal to struct. I think there is no need to write. Fine. So after creating the new node, what we have to do is imagine the new node is created. Here, let us create a new node and let me rewrite the existing linked list also. I'm just redrawing the existing linked list again for more clarity. Now, let me just create this. And initially, the first node previous is null. I am just rewriting the existing linked list again for a clear-cut explanation. And obviously, this is 1000 and it is the first node. Imagine this is 2000 and 3000. Now, step 1. Step 1 created the new node. Step 1 created the new node. For example, new node is created and some data is there. So I am not worried about the data part. And imagine the address is 4000, for example. And the initial values are null. Initially, when we are creating a node, we are keeping both are null. This is the concept of step 1. Now step 2. Because we want to add the new node in the beginning. Because we want to add the new node in the beginning, what you need to do is in step 2, very simple. New node of next node address is equal to first node. Step 2, new node of next node address is equal to first node. When you are writing this, what is going to happen? The null here will be erased and first node means 1000. First node means 1000 and 1000 comes here. Because of the 1000, we are creating a link from here to here. Now, the existing first node, let me write step 3 here. Step 3 is the existing first node's previous node address. Earlier it was null because that was the first node, but now new node is going to be the first node. So you have to write first node of previous node address. That means step 3 will erase this . Let me just redraw here because of the annotation, 1000 was gone. So this null will be replaced with 4000. That is the new node. So here 4000 will come. Because of this 4000, we are creating a link. There is no link in the system, but it's only for our understanding. We are creating a link in this way. Now you see who is the first node. The position where the pointer new node is there. That is the first node. So our assumption is always the first node should point to the beginning of the linked list. Step 4 is always the pointer first underscore node shall point to the beginning of the DLL. So because of that, so write the statement something like this. First node is equal to 4000. But I cannot write directly. So what you are going to do? First node equal to new node. whatever is the new node. So I'm not putting semicolon sometimes, so don't worry about it. It's only the logic. So step 4, what it will do? It will remove the first node from the 1000 and keeps the first node here. It comes here. That's all. Now you see the existing linked list and the updated linked list. Hope everybody understood clearly. So step 2, it has created this one. Step 3 created this one. And step 4 brought first node here. Hope everybody understood. If you have any doubts, please let me know. So when I am going to share the screenshots, I have taken many screenshots today also. See here. This is the existing linked list, step 1. Then step 2. Okay, initially a new node is created and null were placed. Then step 2 removes the null and creates 1000. Because of that, a link is formed. Step 3 removes the null and keeps 4000 and a link is formed. Then step 4 removes the first node and keeps it here. So that's the updated linked list. Step 2 is doing this, 3 is doing this, and step 4. So if you run my screenshots continuously, you will get a more clarity also in terms of some kind of graphical representation. Okay, any more doubts? Any doubts on this? Okay, so if there is no doubt, let us open the program and see whether these steps are written or not. Adding and display we already saw. Insert a new node. Then see, again in insert, we are calling 3 options. 1 means beginning, 2 means ending, 3 means after a specific node. So case 1, it calls create new node. Then what is create new node? Yesterday we already understood. It creates a memory and then it keeps the addresses are null. Okay, for a better understanding, first let me put previous node as null and then next node as null. It's okay. The order does not matter, but still for a better clarity. So make the previous node as null, read the registration number, read the name, read the CGPA, put the next address as null and return 1. When it will return 0? When malloc fails. So in insert function, step 1 is creating the new node, this one. Create the new node. Step 2, new node next is first node previous is new, and finally make the first node as. So this is step 1, step 2, step 3, and step 4. Exactly the logic has come to the program. So logic is important than writing a program always. Not 1 time or 2 times. Any in your career or in your academic career or job perspective or research perspective, whether you are a BTech student MTech or MCA student or BCA student or a research scholar or a PhD holder, whoever you are, when you want to write any program, don't write any program without the logic. Hope everybody understood. Let us see the next concept, that is in insert scenario, inserting the last node. It is exactly like adding a new node. Adding it in the creation time, whatever we have done. So let me insert a new node in the end of the existing DLL. That is the scenario. And what is the logic? So for that, let me take a existing DLL. Imagine there are 3 nodes in the existing DLL. And this is 1000 and first node pointer. First node. And this is 2000, 3000. And obviously, we are not worried about the data part. We are only worried about how to manage the addresses. So I am not writing any data here. So imagine you have null. First node previous is always null, and last node next is null. You have a link. This is the existing linked list. Now, what are the steps? Steps for adding a new node in the end. In the end. Let us see. Step 1. Travel to the last node. How to travel? Simple. Last node for last node equal to beginning, that is first node, then last node of next node address not equal to null, move the last node to the next node address. So this particular loop will make last node starts its journey from first node. That means it comes here and stops. After that, it verifies the next pointer. It's not equal to null, so it moves. Again, it verifies this. It's not equal to null, it moves. Now it verifies here and it does not move. It stops here. Now last node is here. Now, obviously, step 2 is create a new node. Create a new node. So by using the same, like read data and keep both the address fields as null initially. So step 2, let us imagine, creates a new node. With null as the previous field and null as the next field as well. And we are not bothered about the data. New node has come. Imagine it is 4,000. So step 2 has created. Now, because we want to add in the ending, now the current last node, okay. So everybody, it is very, very simple if we understand the logic. But directly, if you see any program, you will not understand anything because so many pointers, this of next and x of next, y of previous, so many concepts. Okay. Step 3 is last node, next node address. It's equal to an English only now. If you see my logic and the C language statement, it's look like English only. Only arrow will come and the name is having underscore and all. Last node, next node address is equal to new node. So this particular step 3, it will remove the null here and keeps 4,000. Because of this 4,000, we are creating a link. Link is our understanding. There is no arrow in the system. It creates a link. Now, simple. Step 4. Step 4 is new node, previous node address is equal to last node. The existing pointer of the last node, right? So step 4 removes the null and creates 3,000 inside. So because of this 3,000, you are going to get a link in this way. That's it. Now you see the updated one. It's done. So this is the existing. Okay, now I think I should not write existing or anything. From there, finally, this is the updated linked list. Updated linked list or updated DLL. Updated DLL. Now, let me clear the annotations. I have taken the screenshots. So let us just quickly navigate with the screenshots. Yes, insert a new node in the end of DLL. So this is the existing steps for adding. Travel to the last node. Last nodes checks everything and stops. Then create a new node. Yes, it is created. Last node, next address equal to new node. It removes the null and keeps 4,000. Because of that, link is formed. Now new node of previous is equal to last node, so it removes the null and keeps 3000. Because of that, there is a link. That's it. That's the updated DLL. Hope everybody understood. So see here, step 1 means creating a new node. In my logic, I told travel to the last node, but much before traveling, we are creating the new node every time. So see here, travel in the for loop, travel to the last node next equal to new node of previous equal to last node. That's all over. Same logic, English like logic. That's why I use the names very big. Last node, a next node address, previous node address. I took lengthy names so that when you are writing the logic itself, you will write the program actually. Any more doubts here? Any more doubts? Okay. Now, let us see the next scenario. That is inserting after a specific node. Inserting after a specific node. This is exactly like a searching like a in a single linked list, but now there are some additional pointers to be manipulated. So let us see by making use of our scenario. Scenario is insert a new node after a specific node. Specific node in the existing DLL. The existing DLL. So what is the logic? What is the logic? So for this, let us take an existing linked list. Existing DLL. Imagine now, let me write the data also. Okay, anyways, let me keep the pointers. And you have null. The first node's previous is null. Last node's next is null. Now try to write some data. 1 Raj 9.23. 2 Ram 7.2. 3 Yash 9.89. And imagine this is a link. Zoom is really good in giving so many annotations, and I think I am equipped nicely with Zoom. I like Zoom a lot because in a more realistic way, like a graphical representation, we can use so many features, right? So this is the existing linked list. Now, what we need to do is, let us imagine I want to add Avinash after Ram. So, imagine step 1, obviously, create a new node, read data and keep both the addresses as null initially. Obviously, this is always the step 1. That means step 1 creates a new node. For example, new node is created. Okay. Fine. So this is, imagine this is 4000 or new node. This is the new node. Fine. So initially you will have null in both the addresses, and the student data is roll number 4. I want to insert in between Avinash 9.7. Now, this new node should come in between Ram and Yash. Okay, so what is our imagination always? First node points to, imagine the first node pointer always points to the beginning of the linked list. And imagine the addresses also. This is 1000, 2000, and 3000. Now, step 1 is we created a new node. Now, what should happen? You need to ask after which node you have to add. For example, the specific node is registration number 2. That means in between Ram and Yash, we have to add Avi. Okay, so we have to go till that specific node and stop. Step 2 is go to the node where you need to add the new node. Go to the node after which you need to add the new node. That is step 2. So how I can go there? How to travel? Exactly like single linked list. For last node, see last node or temp node, you can take anything. Okay, so let me just see what I have used in the program. Okay, I used temp node. I used temp node in my program, so let us take temp node equal to first node, temp node equal to first node, then temp node of registration number not equal to, we are taking a variable called as search registration number. If it is not equal to, move the temp node in a forward direction. So this particular loop will start the journey of temp node from the first node. So temp node comes initially to the first node. That means it will move and settles here. After that, first temp node of registration number 1. 1 is not equal to 2. So it moves here. Now what is temp node of registration number 2? 2 not equal to search registration number 2. It stops. Now after temp node, you have to put last node, sorry, new node. Okay, so everybody please see here. A simple way of adding. I am explaining you a simple way. There can be many ways. Okay, a simple way is, everybody see here. Last node equal to temp node of next node address. See, I am telling you the most simplest way. Last node equal to temp node of next node address. Okay, so that means what will happen? Last node will come. Last node pointer will come and sits in temp node next node address. Temp node next node address is 3000. So this particular step 3 makes the temp node, sorry, last node makes the last node moves its journey till here. Now it is very simple. Temp node is there, last node is there. In between you need to add new node. Just to see how easy it is. Step 4 is update the links, and all the things I am writing as step 4. How to update? Very, very simple. See here. Or directly, let me write like this. Now the steps can be interchangeable also. Okay. What are the steps I am going to explain? It can be interchangeable. Now everybody please observe. Temp node next node address. Temp node next node address is equal to new node, because new node comes in between temp and last. So step 4 breaks the link I don't know why this is not getting removed, but anyways, it will remove the link, everybody, and keeps. For example, if new node is 4000, imagine new node is 4000. So 4000 will come in the temp node of next node. That means, see here, 4000. Because of this 4000, Because of this 4000, we are going to get a link something like this. Drawing the links are little tough for double English because so many links are there. Okay. Then next, step 5. Step 4 to all the other steps are interchangeable also. Step 5 is new node of previous node address is equal to temp node. New node of previous will be temp node. That means it will erase the null and keeps 2000 and keeps 2000 here. That is the temp node. And because of this 2000, a link will be formed. Okay, the links may look very ugly, so just forgive me for that. A link is formed in this manner. A link is formed. Now, step 6. By this time, everybody might be imagining why I am telling slowly. By this time, you will understand. Step 6 is new node of next node address, or let me do one thing. Last node, and these steps are absolutely interchangeable. Step 4, 5, 6, 7, you can write in any order. Last node of previous node address equal to new node, because new node is coming in between temp and last. So last node previous will be new node. That means step 6 will remove this link and keeps 4000 here. That means this 4000 creates a link. It creates a link like this. I can directly say, instead of writing so much, it creates a link like this. Basically pointing. Previous is this one, the node. Don't see the arrow is coming to data. It is not about that. It is the base address. And the last step is step 7, new node, next node address is equal to last node. So step 7 creates a link in this way. It removes, it erases the null for AVI 9.7. Okay. For AVI 9.7. Basically, it erases the null and keeps 3000. 3000 makes a link created in this way. So now the double linked list is created with the updated links. So updated DLL. I forgot to write one small address, I think here. It's 2000. So any doubts you have, you can ask me now. So I have again created the screenshots so that you can also randomly run and try to understand. Insert a node after a specific node. This is the existing. So create a new node. A node is created. First node is here. The addresses are there. Specific node is 2. Go to the temp node. So temp node starts the journey and stops. Last node is standing after the temp node. Then we are creating the new links like this. So any doubts? Step 4, 5, 6, 7 are interchangeable. I already wrote till I told Swami 4, 5, 6 times I told. Roll number 5A9. Step 4, step 5, step 6, step 7. You can rewrite in any manner because we have temp node, we have new node, we have last node. Temp next is new, new previous is temp. Last previous is next, and new next is last. You can interchange. So the same thing is mentioned here. Okay. So exactly same thing. I don't know whether I interchanged or not, but see, last node equal to temp. Then new node of next is last, node previous is temp. Temp next is new, last previous is new. So there is an interchange also, right? So line 173, 174, 175, 176 order can change. Order can change. No problem at all. Any more doubts? Now let us try to execute. Let us try to execute the complete scenario by compiling freshly. Compiling. So today we understood all the insert scenarios. We understood all the insert scenarios right now. So if you want, we can always add the node first. Registration number 1, ABC, CGPA is 1. Continue, insert node, registration number 2, DEF, pointer is also 2. Just for speed explanation, I am just typing randomly. I am not typing any meaningful data. Now you see there are 3 nodes. 1, ABC, 2, DEF, and 3, XYZ. Now I want to add. Let me add. Sorry, insert. So option 2, insert in the beginning. Let me add 101. Yes, 9.89 in the beginning. Do you want to continue? Yes. Display. Now see, let me just decrease a little bit. Now you can see Yash is added before roll number 1 ABC. Hope everybody understood. Now, do you want to continue? Yes, I want to continue. Again, I want to add. In the end, let me add 10111 Abhiram 8.67. Do you want to continue? Yes. Now I want to display. Now you see Abhiram has come after XYZ. Let me reduce the font so that we can see all together. Yes. Now you can see. Do you want to continue? Yes, I want to continue. Insert a node. Yes, insert after an existing node. Option 3. Now it asks, let me add after roll number 1, ABC. So I entered 1. I entered 1 here. See here. I entered 1. Then registration number 200. Swami 9.56. Now Swami will come in between ABC and DEF. Do you want to continue? Yes. Display. Now you see Swami came between ABC and DEF node. So let me just reduce so that I can take a screenshot. Yes. Now you can see. Earlier ABC DEF, now ABC Swami DEF. So that is about the insert operations. So do you want to continue? No. Hope everybody understood. So take a couple of minutes break now. Take a couple of minutes break and we will meet again at 6:10. Now the time is 6:07. We will resume our session at 6:10. In a minute, we will resume the session. So now let us resume our session with deleting the nodes in the existing double linked list. I hope there is no doubt in the insert scenarios. Let me go to the chat box and see if there is any doubt, or can I proceed further? I hope there is no doubt. So now our scenario is to understand how to delete the first node beginning. Scenario is deleting the first node in the existing DLL. Deleting the first node. So what is the logic? What is the logic? So for that, let us take some existing DLL. Let me take an existing DLL of 3 nodes. And we should always bother about the how to handle the address, but not the data. Data is a simple thing, right? If data is wrong, nothing will happen. But if the addresses assignment is wrong, then it is gone. The main trivial part in implementation of linked list is how best we can handle the addresses. Data is only just an indicative. It has nothing to do with our implementation. Data can be anything, but addresses cannot be anything. It should be perfectly managed. So imagine this is the existing linked list, and obviously you have the base addresses 1000, 2000, 3000, just an indicative base addresses, and first node always points to the beginning of the linked list. This is the existing linked list. Now I want to delete the first node. I want to delete the first node. Okay. Now here there are 2 cases. Imagine there is only, okay, in this case, if there are 3 nodes or 2 nodes, more than 1 node, existing DLL, more than 1 node. There are more than 1 node. So 2, 3, 4, 5 like that. Now what we have to do, let us see. Step 1, take temp node as first node, next node address. First node, next node address. So step 1 will bring temp node, to the second node in this scenario. First nodes next means 2000. So it will come here and settles. That means now we have to remove the node where first node is pointing to. That is the concept. Delete the first node, right? So step 2, free first node. So step 2 makes this entire thing back to heap. Back to heap. Back to heap. That means this is gone. This entire node is gone. Okay. That means this link is also gone. But the temp node link is still there, but the location is not available in our program. So after that, what we have to do? Who is the upcoming? So step 3. Bring the first node back to the beginning of the linked list. So first node equal to temp node. That means what is going to happen? This is removed and first node is equal to temp node. That means first node comes here. Now both first node and temp node are same at this position. So I can write step 4 as first node previous node address is equal to null. That means right now first node is 2000, temp node is also 2000. So either you can write like this, or you can also write temp node of previous node address is equal to null. Like that. You can also write in this way. Both are same. Why? Because temp node equal to first node. Both are same. So this it removes, whether here null is there or not, we should not bother. It removes the link there and keeps null. That means we have the updated DLL. So this is the existing, the entire one, but now this is the updated. Updated DLL. I hope there is no doubt in this explanation. So if you just want to see the screenshots and move it fastly, right? So let me just check. Yeah, deleting the first node. So this is the existing thing. If you have more than one node, bring the temp to the second node, free the first node back to heap, first node equal to temp node. So bring the first node here, then first node previous, remove the link and keep null. But now, if there is only one node, see here, if there is only this point, I didn't tell in the single linked list. So you can also go back and change accordingly. If you have only one node, just imagine, delete the first node in the existing DLL and In case if there is only one node, then temp equal to first of next will not work because there is no second node, it is null. There is no need of temp here. Why? Because if there is only one node, simply free it. That's all. I hope everybody understand what I am saying. If you have only one node, then what you have to do? Imagine there is only one node. Okay. If there is only one node, how it will look like? It will have null. It will also have null, some data, right? And imagine this is 1000. First node and imagine this is the existing DLL with only one node. In that case, no need to take temp and all. It's not required at all. Okay. If this is the existing linked list, how you will delete? Simple. Step 1. Free first node. That's all. Free first node. That means what? This entire thing is going back to heap. Going back to heap. That means this is gone. And here, step 2. See, you are releasing the location 1000, but first node is still having 1000. So make first node equal to null. Why? Because empty DLL. Empty DLL means first node should be null. That's it. This is the concept of deleting the node, but where there is only one node. Delete the first node. Suppose you are saying delete the first node, but there is only one node. Then what you will do? No need to take temp equal to first of next. Then delete the first and bring the first back. There is no need. Hope everybody understood. So let us see the delete scenario. Yes, if first node is directly null, linked list is empty. Otherwise, we are asking delete the first node, delete the last node. Suppose if first node next is null. If there is only one node, how you will know whether there is only one node or not? If first node next is null, that means there is only one node. There true when only one node is there. If only one node is there, do it in this way. Otherwise, take the temp as first of next, free the first, make the first back to the second node, which is the upcoming one, and first of previous equal to null. Any doubts? Any doubts? Whatever I explained, both the scenarios are here. Any doubts? Today, very less response in the chat. Nobody is responding whether they, okay. Other than Yashwant Swami, very few people have responded today. It's okay. Okay, thank you. Thank you. Thank you now. Now many people are responding. That's good. Yes. Always you have to respond. Then only it will be an interactive session. Otherwise, I will keep on talking like a radio FM, and I don't bother about. Always our lecture should be a connection-oriented protocol like TCP/IP. I will tell something, you acknowledge. You tell me, you ask me something, I respond. But it should not be a user datagram protocol, connectionless service, which is not reliable. Okay. So now, how to delete the last node? How to delete the last node? To delete the last node, stop one node before the last node. Same concept. So let us come and the scenario is delete the last node in the existing DLL. See, here also you can verify. Here also you can verify whether there is only one node or not. I am leaving up to you now. See, you can also always improvise the program which I am explaining by checking so many conditions. Okay, but I believe there are more than 2-3 nodes, and keeping in that mind, let us see. Existing DLL. Imagine there are 4 nodes. And obviously this is null. And it will have so many links. First node previous is null. Last node next is null. And you have the links. When there are more than one node without using free first node, can I say first node next address is null? Soumya, but you have to release the memory, right? You have to see in dynamic memory allocation, what is the advantage? When you want, you will ask. When you don't want, you have to release. If you don't use free, what will happen? You will keep on taking, but you will not release. Then heap will be full. Soumya. Okay. So imagine this is the base address 1000. I think there is no need of writing so many base address and all, because now we are matured enough. So in this existing DLL, what we have to do? Stop at step 1 is go to the last but one node. How to go? I think everybody knows, by giving 2 level of next addresses. So that means you are going to write for last node equal to first node, last node, next node address, again 1 level of next node address is not equal to null, then travel ahead. Last node equal to last node of next node address. Last node of next node address. So in this way, you are going to the last but one node. So I am directly writing. I am not explaining so much in detail because we already had such kind of discussion earlier also. So last node comes here. Now I have to delete the next node of last node. Everybody see. Step 2. Delete the existing last node of the DLL. I am not talking last underscore pointer. I am not talking about the last node pointer. I am talking about existing last node. Okay. So the pointer last underscore node is stopped at last but one. So how to reach the last node in the DLL? Simple. Last node, next node address. This is the existing last node. So free last node, next node address. That means, imagine first node is 1000, 1000, 2000, 3000, 4000. So last node is 3000. Last node, next node address is 4000. So this means free 4000. What I mean to say, imagine this is 1000, 2000, 3000 and 4000. Where is 4000 stored? Here. What is this particular, this one? Last node, new node, next node address. This is last node, next node address. This particular box is last node's next node address. That means what is going to happen? It will remove. It will remove this 4000. That means, once again, free will make this back to heap. Back to heap. That means this is gone. It will be given back to heap. Now what you have to do is step 3. Now the last node is the pointer last underscore node. Last node, next node address. That means the box inside the last node is equal to null. Why? Because last node will always point to nothing. So you are going to keep null here. When you are keeping null, that means this link is gone. That's all. Now you see the updated linked list is perfectly all right. This was existing, and this is the updated. Hope everybody understood. Same thing will be written here. You see, travel to the last but one node. Here I am putting temp node. There I wrote last node, but both will be same. If you have any doubts on that, you can also say like this. Last node every time, so that my program and my explanation has same name. Because both these pointers are used for navigation only. So let us try to execute it. GCC -O. Now let us delete the last node by creating some nodes. Let me create very fast. Add the node 101 yes 9.67. Do you want to continue? Yes. Add the node 102. Abhiram, CGPA is 9.34. Do you want to continue? Yes. Add one more node, 103. Let me add myself. Nagaraju, 9.23. Do you want to continue? Yes. 1, 2, 3. 3 nodes are there. Now I want to delete the second node, the last node. So I gave the option 3, that is delete. Now delete first, last particular. I want last. Do you want to continue? Yes. Display. Now you see Nagaraju is gone and Abhiram became null. Why? Because earlier Abhiram next node was Nagaraju, but now because Nagaraju is removed, Abhiram will point to null. Hope everybody understood what I am saying. If you have any doubts, you can ask me. So earlier Yash was pointing to Abhiram, and this was pointing here, but now Abhiram points to null because this is deleted. Okay, do you want to continue? I don't want to continue the program. So let us come out, clear the screen. And now the final concept of double linked list is deleting a specific node. Deleting a specific node. So obviously it is like the same. First you will search some registration number, then stop at that registration number where you want to delete and then do some activity. So this is the basic program. You can always improvise yourself. This is the most difficult part of any student is understanding concept by writing one board. Okay, this node connects this. But if anybody is asked to write a program, I think 99%, some brilliant students, they will always do it. But 99%, a student like me, when I studied, they are always scared of programming. But now you see, in front of you, I am able to explain the program. I can write. If there is a challenge that you do this, I can start writing from the scratch. I will try to jot down the logic and finally I will write the program. And whether you believe it or not, After almost 2002, after 18 years, I am writing the code for practicing myself only in this session. I never see any textbook or anything. I just close my eyes, draw some diagram, and open the program and start writing the program. Usually I wrote on the board the complete code and dry run. But now because it is online, I have to explain. So I started writing a program by myself first. Today, I will write tomorrow's program. If you really believe or not, you can see if I display all the things, I started already writing. See here. Circular double linked list I started writing today only, before the class starts. Even the 10 minutes gap, you joined at 5:10, right? You see, I was writing in the background. At 5:10 only I saved. When Ramakrishna sir told, let us start the session, then I closed this and started the session. So, if you know the logic, at any point of time, you will be able to write the program very easily. And not only this basic program, anything they ask in the linked list, it's very easy to write. Okay, so delete the specific node in the existing DLL. Delete the specific node. Scenario, we will try to understand the logic. Scenario. Okay. So, let us take one existing linked list. Existing DLL, and then let us try to write the pointers. See, my drawing may not be good. I may not be able to write equal level of things, but the first node previous C is null. Last node next C is null. Imagine the data is 1, Raj 9.23, 2, Yash 9.89, 3, Ram 7.2, and 4, okay, less space is there, so don't worry. Abhi 9.7. Okay, now I want to delete Ram. I want to delete Ram. That means now Yash should point to Abhi, Abhi should point to Yash if Ram is deleted. So let us create the links. This is the existing linked list. Existing linked list. And imagine there is only one assumption always. First underscore node pointer always points to the first node. So this is 1000, 2000, 3000, and 4000. These are the addresses. Okay. Now, task is delete registration number with 3. So we are taking search registration number is equal to is 3 now. That means we have to delete the node where Ram is there. Okay. So what is the step for that? Step 1. Go to the specific node or go to the node, I think, one step ahead of that, I think. 1 second. Just hold on. Let me see what code I have written so that my explanation and the code will exactly look same. Okay, temp node, I stopped there. Temp node of next node address. My power is gone. So I wish the generator will come so that you can see me. I hope you are able to see the screen. So in the loop, I have taken temp node, next node address. Just hold on. I am not able to see my keyboard properly. Power is gone. Let's hope the generator. Yes, generator is on. Yes. So what I am doing is I am coming to the node which I want to delete. Temp node, sorry, stopping one node before. Stopping one node before. Always we do like that because the proverb is don't cut the branch where you are sitting. So step 1, stop at the node or stop one node before the node to be deleted. Stop one node before. Stop one node before the node to be deleted. See, my English is very pathetic. Stop one node before or prior to the node which you want to delete. I think this English is little better. Stop one node prior to the node which you want to delete. Fine. So that means for temp node equal to begin the journey from the first node, temp node of next node address in that registration number. So by standing in Raj, I am seeing Yash registration number. By standing in Yash, I will see the registration number of Ram, like that. So this is the same logic we used earlier also. Then temp node equal to temp node of next node address. So this particular loop will stop the temp node one node before. That means, so let us try to understand. Temp node will start temp node equal to first node. Okay, that means first temp node will begin from here. Now temp node next node registration number 2 is not equal to 3. Oh, I forgot to write that. So I am extremely sorry for that. I have to rewrite. Step 1. Which is prior to the node that needs to be deleted. Sorry guys, I wrote the loop wrongly. That means for temp node equal to first node. Yes. After that, temp node of next node address, next node address in that registration number not equal to search registration number, then move ahead. Temp node equal to temp node of next node address. Next node address. Now this step starts the temp node from the first node, checks the condition, temp node next node registration number 2 is not equal to 3, so move. Now temp node next node registration number is 3, so don't move, stop here. Okay. The address of double linked list is not proper. Brunda madam, which was not proper, madam? Brunda madam, I could not understand. The address of double linked list is not proper. 1000, 2000, which is not proper, madam? I could not understand. Can you please, if the addresses are not. Roll number A1234. If the address are not proper means, I am not able to understand. Lolla Naga, something name is there. Is there any problem in the diagram what I am writing? How can we predict? Roll number A1234. Who told that address will be known to us? I am only writing a example 1000, 2000, 3000, 4000. Nobody can predict the address. For our explanation, I am writing, but the link is the main address. The link which you created while creating the linked list and inserting is the thing. In the program, everybody see here. In the program, I never wrote anything. Only next address, previous address, like that only I will write. I will never put 1000, 2000 in the program. Hope everybody understood what I am saying. Any doubt? Yeah, okay. Brunda madam, I still didn't get your thing, but anyways, let me, Abhiram, in deleting the first node case, if we release the memory of the first node and before we make the upcoming first node's previous node as null, where does the, in deleting the first node, in deleting the, 1 minute, Abhiram asked one doubt. In deleting the first node, okay, case, if we release the memory of the first node and we make the upcoming first node as null, okay, upcoming first node as null, okay. Where does the upcoming first node, previous node point to? First node previous is always null, right, Abhiram? Okay, let me take the queries after the session because some survey forms are also being given. I don't know what is that. Anyways, first let me continue. Now, in the next step, step 2, Do this. Last node equal to temp node next node address. Okay, that means go to the node which you want to delete as last node. Okay, that means this particular step will take my last node here. My last node here. Now, everybody see, this is the node to be deleted, the last underscore node. So after that, what I have to do? Everybody please observe. If you directly delete now, then you can't reach the other node. You can't reach the other node. So listen carefully. A little tricky part may come. Okay, so listen carefully. One second. Step 3 is temp node next node address equal to temp node next node means the node of Yash to Yash 9.89. In that next node address field equal to last node next node address. That means Ram's next, that is Abhi 4000. So step 3 will erase this link. Everybody please see here, and keeps last node next node address, that is 4000 here. That means what? That means we are creating a new link. We are creating a new link in this way. This is the new link we created from step 3. Now in step 4, now if you understand this particular step, that means you genuinely understood the concept of pointers, because there might be a small confusion here. See here, step 4. Everybody please carefully listen for 2 minutes now. This is the last, but after that only free is there, releasing. Last node, next node, previous node equal to temp node is written. Okay, that means to understand, break it. Break it means, see here, take this one and divide that into like this. Last node, next node address. That means what? Last node, next node means 4000. Last node, next node means 4000 node, 4000's nodes, previous node address. Is equal to temp node. That is the understanding. See, last node, next node means don't see. Everybody, I am telling you, last node, next node means people may get confused this box. Last node, next node is that box, but I am not referring to the field. I am referring to the address. Last node, next node, address. Sorry. Sorry. People may think last node, next address is this box. I am not talking about the box. I am telling last node is 3000. Everybody see here. Last node is 3000. So last node next means 4000. So last node next in bracket previous means 4000's node previous field. Okay, that means, so I am just explaining again. This means here, that means this particular box, 4000 nodes previous field is the box inside. Okay, is equal to temp node. That means 2000. That means 2000. This step 4 erases the link and creates a new link like 2000. So it creates like this. Now, obviously, the final step, step 5, free last node. That means the last node is going back to heap. The last node is going back to heap. What does it mean? This part is gone back to heap. That means it is completely removed like this. This is gone. So by mistake, because of annotation, this is also there. So this is gone. Now you see the updated linked list, updated DLL. So that's it. That means let me clear all the annotations. Let me clear all the annotations and then show you the fast running of the screenshots. You want to delete the specific node. These are the addresses. The task is to delete RAM. So move the temp node and it stops. Then last node starts here. Then remove the temp node next and keep 4000. That means a new link. After that, go to the previous of the existing the last node and make a new link. Then free means it is removed. That's the updated DLL. So let me just execute the program by compiling again. Let me open whether it is unsaved or not. Yeah, it is completely saved. So let me just compile in front of you again so that there is no magic. And let me execute the. Oh, sorry. By mistake, I typed C language program. So let me close this. Yeah, now let us execute. Now you execute all combinations of scenarios in your house when I am giving the program. It will work. Okay. But only thing is, if you want to delete a specific node, I think you have to mention properly. Otherwise, suppose you can't delete a specific node when there is only one node. I have not designed the program in that way. So if you want, you can also improvise. So 101, yes, 9.45. Do you want to continue? Yes. Do you want to display? Now you see the first node previous is null. First node next is also null. Let me continue. Insert the node in the end. For example, insert the node in the end. Once end means there is only one node. So I am selecting insert in the end. Suppose Abhi 9.12. Do you want to continue? Yes. Do you want to display? Yes. Now you see after yes, Abhi came. Now yes next is Abhi. Abhi previous is yes. Abhi's next is null. Hope everybody understand. Now, do you want to continue? Yes. Then again I will ask insert. After a existing node, and the existing node I want to give 101. So let me put 111. That is Swami 8.78. In between means basically after yes. Do you want to continue? Yes option. Now you see Swami came after yes. Do you want to continue? Yes. Let me again insert in the end 105. Let me insert myself Nagaraju 9.23. Do you want to continue? Yes. Do you want to continue? Yes. I want to display. Now you see after Abhi Nagaraju came. After Abhi you see Nagaraju is there. You have to scroll because the font size is big. Do you want to continue? Yes. Let me delete Nagaraju 3. Delete the last node. It's deleted. Let me display. Now you see Nagaraju is gone. Do you want to continue? Yes, I want to continue. Let me delete Swami here, who is in between after Yash, before Abhi. So delete a specific node. Enter your option delete. Delete a particular node. Which node? 111. Do you want to continue? Yes. Do you want to display? Yes. Now you see Swami is gone and Abhi came. Do you want to continue? Yes. Do you want to delete? Yes, I want to delete. First node I want to delete. That means yes should be gone. Yes, continue. Display. Now you see yes is gone. The moment yes is gone, Abhi's previous became null. Earlier Abhi's previous was yes. Do you want to continue? Yes. I want to again delete. Delete the first node. That is the scenario I explained if there is only one node. Now yes is deleted, looks like. Now you see linked list is empty. That's it. So I have taken 1 minute extra. 7:11. I started at 5:11. Now I am stopping the sharing. Over to the host institute. If you have any doubt, you can ask me. Now 3 different variants, complete scenarios. I have explained everything. So tomorrow, circular double linked list. It is an extension of double linked list. All the creation, display, insert, and delete. I will explain tomorrow session. Thank you. for this opportunity. Now, if you have any doubt or feedback, you can always ask me. Over to the host institute. Who is there in the host institute? Let me just check. I think Ramakrishna sir is there.
Yes, sir. Yes, sir.
Yes, sir. Now I'm giving control back to you, sir. Thank you.
Okay, sir. Thank you, sir. Dear participants, thanks to all. And I hope all the participants understood very well today's concept. I'm sending one link to you in WhatsApp groups and Telegram app also. Please give me your valuable feedback to improve our program. Please give me valuable feedback.
You can unmute yourself and you can speak. Anybody.
Yes.
See, I am keep on explaining. This is the 13 days. That means almost 26 hours I spoke. So I am also expecting somebody will come online and they can tell how they felt about the program, how it is going on. Myself, I cannot believe that 13 days are over. Okay.
Yes, sir. Yes, sir.
I can see they are chatting in the chat box.
Abhiram, sir, Abhiram is raised the hand, sir. I can unmute them.
Yeah, roll number 583, Abhiram.
Sir, good evening,
Abhiram.
sir.
Good evening,
Good evening.
Abhiram.
Sir, ఇందాక డౌట్ పోస్ట్ చేశాను కదా సార్ చాట్ బాక్స్ లో. అదేంటంటే సార్ మనకి లింక్ లిస్ట్ ఉంటుంది కదా సార్, డబుల్ లింక్ లిస్ట్. దాంట్లో ఫస్ట్ నోట్ డిలీట్ చేయాలనుకుంటే దాని తర్వాత నోట్ సెకండ్ నోట్ అనుకుంటే సార్, సెకండ్ నోట్ యొక్క ప్రీవియస్ నోట్ అడ్రస్ లో ఫస్ట్ నోట్ యొక్క బేస్ అడ్రస్ ఉంటుంది కదా సార్.
అవును.
ఇప్పుడు ఫస్ట్ నోట్ క్లియర్ చేస్తే సెకండ్ నోట్ యొక్క ప్రీవియస్ అడ్రస్ నల్ చేయాలి కదా సార్ మామూలుగా. అది అప్కమింగ్ ఫస్ట్ నోట్ అవుతుంది సార్. నల్ చేయకముందు అదే సెకండ్ నోడ్ యొక్క ప్రీవియస్ నోడ్ అడ్రస్ నల్ చేయకముందు సెకండ్ నోడ్ యొక్క ప్రీవియస్ నోడ్ అడ్రస్ లో సెకండ్ నోడ్ ప్రీవియస్ నోడ్ అడ్రస్ దేని పాయింట్ చేస్తాను అడిగాను సార్.
ఒక నిమిషం కొంచెం మళ్ళీ చెప్పమ్మా. రెండు నోడ్లు ఉన్నాయి. ఓకే. ఇన్ ఫస్ట్ నోడ్ నెక్స్ట్ ఈజ్ సెకండ్ నోడ్ ప్రీవియస్ ఈజ్ ఫస్ట్. Now first node temp node. Imagine first node is the existing first node, temp node is the upcoming first node. Okay. Now your doubt is ఇప్పుడు చెప్పమ్మా.
yes sir, ఫస్ట్ నోడ్ ని ఫ్రీ చేస్తాం కదా సార్, అంటే డిలీట్ చేసేటప్పుడు
ఫస్ట్ నోడ్ ని ఫ్రీ చేసాం. ఓకే.
టెంప్ నోడ్ అప్కమింగ్ ఫస్ట్ నోడ్ అవుతుంది కదా సార్.
అవుద్ది.
టెంప్ నోడ్ యొక్క ప్రీవియస్ నోడ్ అడ్రస్ ని నల్ కింద మనం ఇండికేట్ చేయాలి కదా సార్, కోడ్ లాగా రాయాలి కదా సార్.
చేయాలి, చేసాం కదా.
చేసాం సార్. దానికి ముందు ఆ లైన్ కి ముందు ఎగ్జిక్యూషన్ లో టెంప్ నోడ్ యొక్క ప్రీవియస్ నోడ్ అడ్రస్ దేని పాయింట్ చేస్తుందని అడుగుతున్నాను సార్.
అంటే ప్రీ ఫస్ట్ నోడ్ అంటే దేనికి పాయింట్ చేస్తుందనా?
అంటే ముందు ఫస్ట్ నోడ్ యొక్క అడ్రస్ ఉంటుంది కదా సార్, ప్రీవియస్ నోడ్ అడ్రస్ లో.
1 minute. Okay. So let me just try to explain. So what Abhiram is asking, let me very quickly just keep something like this. There is a node like this. Imagine this is first node. This is temp node. And this was null earlier. This is having something like this. So this is the current link and this is null and this is null. Now, so first step is temp node is equal to first node next node address. So temp came there. Because of this particular line, temp came here. Fine. Now free first node. That means this is gone. When this is gone, his doubt is what will be the value here. Is that the correct doubt, Abhiram? Whether I understood your doubt correctly? Abhiram, is this your question? Unmute and ask, tell me. If I free the first node, what will be the value in temp of previous? Is this your question? Okay, he responded yes. The answer is, so the doubt is when free first node is executed, and see here, the base address, everybody, when it is executed, what will be there in the temp of previous, sorry, temp node of previous node address? That is the doubt. Okay. That means everybody see. Explanation. When free first node is executed, when free first node is executed, what is first node? It is 1000. That means free 1000. That means release the block which has the base address 1000. That means only this will be removed. This is back to heap. But temp node of previous node address is still 1000 only, because 1000 is written here because of the link. So that's why I am making it will remain 1000 only. Okay. It will remain 1000 only. That is the reason we make, see here, first node equal to temp node, first node equal to temp node, and then first node equal of previous is equal to null. That means we are bringing the first node here and then erasing the 1000. That means the unnecessary link is gone and now you are keeping null. Abhiram, is the doubt clear now? Abhiram, is the doubt clear? Okay, you understood. Thank you. Yes, any more doubts? Thank you, Abhiram. Yes, over to Ramakrishna, sir.
Thanks to all. Anyone is there?
Okay, Yashwant is asking a doubt. Sir, at which purpose Can I travel by using previous node address? You travel now. See, in circular double linked list, I will tell you. If you want to travel back, in which purpose? I will tell you. Yashwant, 1, 2, 3, 4 is the data, but I want 4, 3, 2, 1. What you will do? Go to the last node, print in a reverse manner. Yashwant, is it clear? If you want to print the data in a reverse way, all the data, 1, 2, 3, 4 is the data. Yes, clear. Right. Thank you, Yashwant. Any more doubts? Ramakrishna sir,
Yes, sir.
shall we stop the session, sir?
Yes, sir. Yes, sir.
Okay, guys. Thank you.
1 second, sir. 1 second, sir.
Yes.
Dear participants, I am sending on Google form to you. Please fill your valuable feedback on this form. Thank you.
Thank you all. See you tomorrow.
Please give the feedback. Okay. Once again, I request you all the participants. Please give your valuable feedback on this form. Thanks to all.